In this video, you're going to calculate z-scores and find probability. We're basically putting everything together that we've learned so far. In this case, though, we're starting with the raw scores, we're turning them into z-scores, and then we're finding those probabilities on the unit normal table. If you look at your unit normal table, it doesn't say anything about raw scores. It only talks about z-scores, so we need to make that transformation first. And it is possible to find specific probabilities for raw scores by transforming them into those z-scores. We're going to find the probability associated with a certain z-score. This is a two-step process. First thing we have to do, transform our scores into z-scores, and then use the unit normal table to find those proportions and probabilities. Let's start with an example. What is the probability of randomly selecting an individual with an IQ score of less than 130? And we need some information to be able to figure this out. The mean is 100 and the standard deviation is 15. So the very first thing we need to do is find the z-score. Let's do that. So here we have all the information we need to figure out the z-score for IQ score of 130. So we have the mean, the standard deviation, the score, and we have the z formula. So I'm going to just plug in my score minus the mean of 100 divided by the standard deviation of 15. 30 minus 100 is 30 divided by 15. We have a z-score that is equal to 2.00. So let's take a look at this z-score on the normal distribution. So our z-score of a positive 2 would be right here. And what was the question asking us again? Well, remember that positive 2 is an IQ score of 130, and we were looking for everybody under 130. So I'm going to shade in this area that we're looking at. In other words, we're starting at a z-score of 130, or z-score of 2. We're crossing over the mean all the way to the end. So we are going to use which column in the z-table? Think about it. So we know we have a z-score of 2, and we know we're looking for the proportion in the body because we're looking for everything less than 2, and that everything crosses over the mean and goes all the way to the tail. So we're looking for proportion in B. Proportion in the body is B. And that gives us 0.9772. And we can interpret that by saying that 97.72% of people would have an IQ score of less than 130. So that is our answer right there. What did we do again? We have our raw score of 130. We converted it to a z-score, and then we used that z-score to find probabilities in the unit normal table. Here's another example. Let's say the highway department conducted a study measuring driving speed on a local section of the Interstate 10. And they found a mean of 58 miles per hour and a standard deviation of 10 miles per hour. And it was a normal distribution. The question is, what proportion of cars are traveling between 55 and 65 miles per hour? Or we could say, what is the probability of randomly selecting a car that is traveling between 55 and 65 miles per hour? So let's think, what information do we have? Well, we have two raw scores, so to speak. 55 and 65 are our raw scores. We're going to need to convert those into z-scores, and then we can use our unit normal table to find the probability of finding someone between 55 and 65 miles per hour. So the very first thing we're going to do, let's map it out. Let's find the z-scores for each value. We're going to find the proportion for each z-score, and we're going to add those proportions together. All right, we have everything we need here to find the z-score for 55 and the z-score for 65. So we know that we have a mean of 58 and standard deviation of 10. So let's plug in the first score to find its z-score. So we have 55 minus a mean of 58 divided by 10 is negative 3 divided by 10, which is a z-score of negative 0.30. Okay, we've got the first one. The second speed the higher speed was 65 miles per hour. So let's plug that into our Z formula. 65 minus the mean of 58 divided by the standard deviation of 10 gives us 7 over 10, or a Z-score of positive 0.70. These are our two Z-scores, and we're trying to figure out what is the proportion between these two scores. So let's draw it out to see what parts of the unit normal table we're going to be using. So the lower Z-score was a negative 0.3, so I'm going to put that at around here, about a third of the way to a negative 1. So this is the first Z-score of negative 0.3. The second Z-score is a positive 0.7, so about 70% of the way to a positive 1. So I'll put a positive 0.7 here. So what I'm going to need to do is I'm going to need to use my unit normal table to find the proportion of scores that are between the mean and positive 0.7. So that's what I'm going to need to find first. And then I'm going to have to find all of this, the proportion of the scores that are between the mean and a negative 0.3. All right, so I'm going to find this proportion here, and then I'm going to add all of this together to find the total proportion between a negative 0.3 and a positive 0.7. So let's take a look and see which column we're going to be using. Think about which column you would be using for each of these on the unit normal table. Now that we know what we're looking for, we need to find the proportions that are going to be helpful to us. So our first Z was a negative 0.3. Well, we don't have negatives on the Z table. No worries, just look for 0.3. And we know that we're looking for the proportion between the Z-score and the mean. We shaded that in, and that equals 0.1179. Let's go to the next one. The other Z-score we had was 0.70. And again, we're looking in column D because we're looking for that proportion between the mean and the Z-score, and we end up with 0.2580. So let's take a look and see what that means in terms of what is the proportion between 55 and 65 miles per hour. So from our unit normal table, we saw that the proportion between a negative 0.3 to the mean was 0.1179, and the proportion from a positive 0.7 to the mean was 0.2580. To find out the total between these two Z-scores, we just add up these two proportions. And I'm going to do that very quickly. And we end up with 0.3759. The way that I interpret that is that there are 37.59% of the cars traveling between 55 and 65 miles per hour. I have some more learning checks for you, but I feel like this video might be getting a little bit long, so I will see you at the next video.